Hi, today we're going to look at solving trigonometric equations over a given interval. Now, there's about 6 problems here that you can look at, and it shows you step by step how to do it. I'm going to go over a few just to go over on how to solve these trigonometric equations using the knowledge that we just learned on solving trigonometric equations in general form. So when you get an equation and they give you an interval that they want the solutions to be in between, what you want to do is you want to solve it just like if it were a regular trigonometric equation in general form. So we are going to isolate the theta here. So we're going to move the 1 over, divide by 2. Now, in order to get into this, you need to get rid of the cosine. So from 0 to 2 pi, you have to think of all the angles that will give you a half. Now, the angles that we're going to have to think about have to be in quadrant 1 and in quadrant 4. So that means it would give us pi over 3 and 5 pi over 3. But we want to write it in general form because we want all of them. So we're going to add 2k pi to both because remember the period for cosine is 2 pi. Then this 2 theta will equal that new value. You're going to solve for theta, which is to divide by 2, and this is our general formula. But because we want all the angles, not just all of them, that we only want from 0 to 2 pi, what we're going to do is we're going to let k equal to 0, and we're going to substitute, and we get pi over 6. Then we're going to put k to be 0 for the other equation. That's also going to give me 5 pi over 6. So those are going to be our first 2 solutions because both of these fall in between 0 to 2 pi. Then I'm going to move on to when k is equal to 1. And I'm going to substitute into the first equation. So in order to write k pi, I'm going to be adding fractions. So I'm going to rewrite it as 6 pi over 6. So k is 1, so 6 times 1 is 6. Add 1 is 7 pi over 6. Again, this is between 0 to 2 pi. So that's a solution. And I'm now going to do k is equal to 2 and plug it in. Well, if I plug into 2, I get 12 pi over 6. And if I add a pi, that's going to give us 13 pi over 6. That is already bigger than 2 pi. Because remember, 12 divided by 6 is 2 already. And if I add something else, it's going to go over 2 pi. So that's where I stop. So far we have 1, 2, 3 solutions. Now we're going to do it with the other equation, the 5 pi over 6 plus k pi. Same thing, since we're adding fractions, remember we need to have the same denominator. So we're going to start with k to equal to 1. And we're going to substitute 6 plus 5 is 11. That is still less than 2 pi. Then we're going to try k is equal to 2. Well, k is equal to 2. That's already over. So our only solutions here for this one would be the pi over 6, the 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that would be it from 0 to 2 pi. So before we were just writing it in general form, that would give us all of them, no matter what type of revolution we had. But now they're just asking us, give me only the angles that will work, but that are from 0 to 2 pi. And those would be it. Now let's look at a tangent one, because a tangent one's a little bit different. So with the tangent, you're still going to isolate theta, so you're still going to get your general form. So we're going to subtract 1, divide by square root of 3. So remember, that's the same thing as negative square root of 3 over 3. Now, if you think back, for tangent, in order for it to be negative, it has to be in quadrant 2 and in quadrant 4, which would be 5 pi over 6 and 11 pi over 6. That's what 3 theta would equal. But remember that what we need to add, the period, would be a pi. So here would be k pi. That would be the general form. Then we divide by 3 because we have to isolate theta. So we get 5 pi over 18 plus k pi over 3, 11 pi over 18 plus k pi over 3. Now, we're going to start with k is equal to 0 for both of them. So here, if 0, it would give us 5 pi over 18, and 0 here would be 11 pi over 18. So we're going to start with the first equation. We're really not going to do the second one because remember, when we're graphing tangent, if one is on this side and the other one's here, if I keep adding pi, I'll keep getting this other one. So I'm not going to do this one just like I did here on the previous one that I went to the second equation and I kept going. So what I'm going to do is now go k to be 1. I'm going to plug it into here. And I'm going to solve it. And I get 11 pi over 18, which is less than 2 pi. Then I'm going to do k is equal to 2. So 6 times 2, that's going to give me 12, plus 5 is 17 pi over 18. That's still less than 2 pi, so that's a solution. I'm going to keep going until I can't any further. So k is equal to 3, so 6 times 3 is 18. And then I'm going to add the 5, 23 pi over 18. That's still less than 2 pi. I'm going to do now 4. 6 times 4 is 24, plus 5 is 29 pi over 18. Still less than 2 pi, because remember, 29 divided by 18 is less than 2. Okay, I'm going to go on to 5. So 30. 30 plus 5 is 35 pi over 18. That's also still less than 2 pi. Now, if I put 6 here, 6 times 6 is 36. And 36 divided by 18 is 2 pi. So 2 pi plus another 5 pi over 18, well, that's going to be over that. So then my answers are going to be 1, 2, 3, 4, 5, 6, 7 solutions. So I would write them down. 5 pi over 18, 11 pi over 18, 17 pi over 18, 23 pi over 18, 29 pi over 18, and 35 pi over 18. Okay, again, for the tangent, I don't have to do this one because if I do it, I will still get the same result as well. Okay, so for cosine, sine, all of the other ones, I do need to do both general equations, but for the tangent, I just need to do one of them. But you do need to remember that for the k is equal to 0, you do have to use both. Not really, because you're going to end up getting it when k is equal to 1, but that's just a nice way to remember. Let's do one more here before we finish. Again, they're still asking us to solve this trigonometric equation on that given interval from 0 to 2 pi. So here, this number is already isolated. In order for me to get into the theta, I need to get rid of the sine. So I have to think about what angles will give me square root of 3 over 2. That's going to be in quadrant 1 and in quadrant 2, which is pi over 3 and 2 pi over 3. And I'm going to add 2k pi. Then I'm going to isolate theta, so I'm going to add pi. So I get 4 pi over 3 plus 2k pi. Then I'll divide by 2 here. So I get theta is equal to 2 pi over 3 plus k pi. Again, I'm going to have to continue. So I'm going to divide by 3 here. Multiply by 3 over 3. That was going to be my first equation. I'm going to let k equal to 1. And I get 5 pi over 3. I'm also going to let k equal to 0. So theta is equal to 2 pi over 3, which is also going to be a solution. On the other side, notice for this one, that's 2 pi over 3. I'm going to add pi over 3. I'm going to add pi, so I get 5 pi over 3. I'm going to divide by 2, and I get 5 pi over 6 plus k pi. Again, I'm going to add these fractions, so it's 6 over 6. And then I'm going to start with k equaling to 0. So theta will be 5 pi over 6. So here my solutions is going to be 5 pi over 6. And then I'm going to do k is equal to 1. And I plug it in, and I'm going to get 11 pi over 6 here. But if I go to k is equal to 2, that's going to be over. So my solutions are going to be 2 pi over 3, 5 pi over 3, 11 pi over 6, and 5 pi over 6. Make sure to continue practicing. The more you practice, the better you're going to get at it.